posed that doesn't really have an answer. And so it just really gets your mind thinking to begin class as an opener. So the paradox of the stone is the first question that I'll ask, and it's can God create a rock that is so heavy that even He Himself cannot lift? God is all powerful, or as we theologians put it, omnipotent, so there is nothing He cannot do. So God can create a stone that is so heavy that He cannot lift. Either He can or He cannot. If God cannot lift a stone, then He is not all powerful. If God cannot create a stone that He cannot lift, there is something that He cannot do, create the stone. So this would be a teaching technique or a teaching strategy to begin a class, like I said, to get logical mathematicals mind working. And as we Christians know, God is all powerful and He can do anything He wants. So He can do both of those. We know the answer to that. I was just being a little bit of a devil's advocate with the paradox of the stone. So that's a way to begin a lesson for a logical mathematical learner. And then what exactly makes a logical mathematical learner? This is basically just defined and summarized.
So right here is a definition from Gardner. Gardner describes logical mathematical intelligence as the ability to recognize significant problems and then to solve them. A mathematician seems to sense a solution or a direction long before they have worked out each step in detail. This definition suggests powerful reasoning ability. It also indicates that the mathematical knowledge reaches far beyond the memorization of facts and algorithms.
So it's going to be a little tedious throughout this PowerPoint because, as Gardner says, everything is through reasoning, and it has to do a lot with the mind. That point's going to be brought up over and over again. As Gardner said it, it's just the ability to reason and to think. So this is, let me move this here. This is logical mathematical described. So an overview, it's the capacity to use numbers effectively. It's pretty self-described. They like to use numbers, and they like to rearrange them so they can figure out problems. They like to reason well. They like to go over either a reading or a problem, and they like to find the answer. Sensitivity to logical patterns and relationships. So it's not sensitive that they don't like them, it's sensitive where it's easy for them to pick up on patterns and relationships in any problems or in really any activity, and they like to find the answer.
And then just some ways that teachers can use this in their classroom. You can have categorizing and classifying, so have some list of terms up on the board and then have them categorize and classify them as to where they should be. As you can use this with animals, animals, and then have animals and then different types of animals. And then you can have them make inferences and generalizations, and also hypothesizing, so you can have them hypothesize, and then after you make a lesson, test that hypothesis, does it still work? And also, obviously, the calculation, the mathematical and math.
And hypothesis is going to come up again. A hypothesis is a tool that's really good for subjects other than math and science. It works in science as well for a logical mathematical learner, but for like English and history, anytime there's reading or going over material, they really like to use hypothesis. So it's a good way to assess them, but we'll go over that a little bit later. This is what they think, love, and need. Like I said before in Gardner's description, reasoning is a big thing. What they love to experiment, so science or a science lab is a really good subject for them. Questioning, so anytime a teacher's going to pose a question or a classmate poses a question to them, they enjoy that. They enjoy figuring out logical puzzles and calculating problems.
And some things they need is, Sam stated earlier, materials to experiment with, so they love to do scientific labs, things like that, even biology, not just chemistry. Manipulatives, and then also they like to take field trips to the zoo, or field trip, to planetariums and science museums. This will help them think logically, as science is all logical reasoning.
Okay, and then this is the curriculum development. Specific for logical mathematical intelligence, a curriculum best suited would be a curriculum that makes the learner think outside the box, not just a simple answer. So a subject potentially difficult would be history or social studies, because I know here at WLC a lot of the history and social studies classes, there is some readings, but if you've ever had Dr. Beck class, it's basically you take a test, there's a question such as who was the 16th president of the United States, and it would be Abraham Lincoln. It's just like a simple answer. That's something that maybe a logical mathematical learner would struggle with because they don't have to think too deeply. It's more of a memorization thing. A curriculum that has active activities where a student must either work alone or with partners to find an answer. So an activity closely related to a science lab. Anything where two people can get together, mesh their minds together, and think of answers or, the answers to a problem.
You could have a curriculum that has word problems or potentially equations that have multiple steps. So obviously, logical mathematical works very well in math as it helps the students. And again, going back to thinking outside the box, but also exploring possible answers, such as a discussion after reading in an English class. This gives the student a chance to think of why things happen in the book that were not specifically described. And then, even going back to the social studies and history, it's kind of difficult because it's a little bit harder. But if you can use stats. So like, thinking about like 9/11, number of deaths, and then have them remember that stat, but then also remember why it's so significant to our country.
Some examples. A good example would be a chemistry class where students will be making hot packs. I know I did this in high school. And by using the exact amount of ingredients listed on the how-to sheet, they will find what creates the hottest pack. So there's an exact number of ingredients that will be on the how-to sheet, and the closer you get to the ingredients will make the hottest pack. And I know it's a little competition in class, but it's something that a logical mathematical person or intelligence learner can use all the ingredients to the best they can to find the answer, which is the hottest pack.
And use a poor way is students taking a social studies quiz related to the Civil War, and just having a question like who created the Emancipation Proclamation.
So that's just like a simple one-word answer. Social studies can, anytime there's reading or anytime they have to think more in depth, that works too for social studies. That's just like a specific example, just like a one-word answer. Okay, so classroom management. How to specifically manage a class for a logical mathematical learner. And then Dreiker's logical consequence system is something that was brought up in Armstrong's book, and then we're going to go over that right now. Managing individual behavior, so all students with behavioral problems. This was more for like a really dramatic behavioral problem, so even a little bit violent, but it works for all situations. Dreiker's logical consequence system. It describes the approach of having students chart the occurrence of negative and positive behavior. This way students can see when they usually act out or have good behavior throughout the day and understand when it typically happens and tries to prevent it. So they're just keeping track of any time they're in a good mood and they're behaving well or when they're not. And typically it'll be written on the board by themselves. And that way they can kind of chart it out, and throughout the day they know when they typically act bad or when they or a good part of their day. So just so they know in the back of their mind. Okay.
This has to do with a little rule that you can put into your classroom. If students you can use a stopwatch to keep track of time being wasted, and then write down the number of 30 seconds that it wasted on the board and keep track throughout the day. And doing this, you can then have a consequence of, okay, you guys wasted this much of my time, now you guys have to stay in for recess for this long because you guys were talking or disrupting the class. And you can also have students hold numbers and form groups, like 1 through 5, so mathematical, and then give them a single and then have them find their groups and others with the same number.
And this can also be used for a good thing too. So if the students are really well behaved and they come ready to work in class, maybe they'll get a minute or two extra at recess or something like that. It's not always a bad thing. And then preparing for transitions like we have on our, anytime we make a lesson plan, you can use a digital clock that everyone can see in the classroom and set that time for the next transition. I know there was a little video online that I was going to bring up. I didn't know if we were going to have enough time, but basically a teacher would go through a lesson, any subject, and when it was time for that part of the lesson to be over, the clock would run out. Everybody would know they'd take out their books and get the next subject up. And then how to teach a logical mathematical learner, teaching strategies. Make the students think. That's the best way to teach them. Like we said, it's reasoning, it's getting their mind active. So teaching activities would be brain teasers to like begin a class, problem solving for really any subject. I guess that's easy to be said for math and science. Number games, so if there's a study session before a test or something like that, that would be a good game to use. Critical thinking, and then mental calculations.
And some instructional strategies is to use numbers use math, quantify to help the logical mathematical learner, put it in a logical framework to help them think logically, and then experiment with it. Test a hypothesis, see if it works, see if it doesn't work.
Assessing logical mathematical learners, how to see their progress, and what is most effective. Okay, so ways to show student assessment. Factors associated with the South losing the Civil War. So present statistics on the dead, wounded, and supplies. Like Randy kind of touched on that before, where if social studies may be kind of a hard subject for a logical mathematical learner, they can put it into statistics, so they can go back and they can see who died, how many were wounded, and maybe why they lost the war because of the supplies. Present strategic plans that were not successful and explain why. So basically just war plans in situations where they lost a battle, and they could go back and explain why that happened and what they could do better in their plan.
So here's a way you can develop a character in a literature class, the cause and effect of the character's development over the course of the reading, and also explain both his decisions, both good and bad, thinking logically, and explain why each one is a good or bad decision.
Okay, MI assessment context. Thomas Armstrong created a chart for all intelligences, and it gives examples of what a good assessment would be for all different subjects. So I have some different ones here, but logical mathematical had the same concept for all 8 examples. Develop a hypothesis. On page 141 of our multiple intelligence book in the classroom, Armstrong, in every single one of them, at the end of it for assessment was create a hypothesis. So a test taking, like a paper and pencil test would be okay if there was some multiple choice, but to think deeper at the end, if there was like some paragraphs that you had to write, or if you have to develop a hypothesis, like I said before. He suggests that for any type of non-test taking assessment activities, logical mathematical learners should develop a hypothesis and explain why. This promotes a deeper thinking, something all good logical mathematical learners excel in, and this can create an accurate assessment tool for those specific to that intelligence. Classroom environment. What is the ideal environment for a logical mathematical learner?
So here's an example of an ideal classroom environment: quiet or silent during working time or worksheets and homework, but still allowing time for group to mix ideas together for deeper thinking. You can have a classroom arrangement is very important, as the learner would like straight rows that are symmetric, and this can trouble a student when the class is messy or disorganized. Students also like to see the new information given by the teacher on the board, just like a PowerPoint or even handwritten on the board. And logical mathematical students like themes in the classroom and having routines throughout the day that do not change, so having a set schedule and not changing every day, going to something different. Obviously this creates easier thinking and less stress for the student.
So going back to this second one here where it says messy or disorganized room, like this would be a really nice room for a logical mathematical learner because they like to have symmetric things, or they like to have a pattern to everything, just like they're learning. They like to have the classroom the same way, so just typical rows work good. Okay, now we're going to do the activity. This activity, okay, here's the directions right here. From the website, we'll be looking at a common word problem with patterns that can be easily seen and used. So I'm going to copy and paste this on the internet, and there's this really nice website that I found that has word problems. They're all associated with math. And we will form groups of 3 in which each group will answer the question. Keep it to yourself. I think there's going to be one group of 2 because we don't have everybody here. After the question has been given and everyone has an answer, we'll go over each question and find what the pattern or relation was in the word problem. So basically, there's going to be a word problem, there's going to be multiple choice answers, and I'm going to pick the wrong one on purpose because when you pick the wrong one, at the bottom of the question, it shows you the relationship and the pattern used to find the problem. It's something that mathematical learners do automatically, so it's pretty simple for them, but for anybody who's not a logical mathematical learner, it's a little bit harder. It shows the steps at the bottom. This is a 4th grade level activity in this Common Brain Teaser website for students who invest through logical, mathematical. The quiz relates to the math 4th grade students would be in or would have learned throughout the year. Okay, so I'm going to copy and paste this. If you guys want to form your groups right now, you can. Yep.
Groups of 3.
Groups of 3, and I think there's going to be one group of 2.
Yeah, I think I'll
And then if you all could get out a piece of paper, each one of you guys, I'm sorry, I should have told you that before, just get out a piece of paper and I'm going to have you write down your answer. And then after you write down your answer, before I even pick one, I'm going to have all of you guys tell me your answer and why you picked that, like the pattern you found. It should be pretty easy. Like I said, it's a 4th grade lesson, but if you don't, that's okay because it's going to tell us how to do it at the bottom. So Randy will read it for us.
Here's our first problem. Kristen is reviewing her cell phone bill. When she gets to the text message part, she notices that she sent 4 text messages in November, 8 in December, 16 in January, and 32 in February. If this pattern continues, how many text messages will Kristen send in March?
Okay, so find your answer. We'll give you like 30 seconds for an answer, if that. And then we'll just pick on a random group and you can give me your answer and explain why. You can pick something. Okay, go ahead.
Alright. Brent, you got an answer for us?
64.
And why did you pick 64?
Because the pattern is it's doubling every month.
Okay. So I'm going to pick the wrong one on purpose. And then if you look down here, it shows us the pattern, which just times into every time, multiply by 2. Pretty easy answer. I got it right. Okay.
Mr. Mattheis.
Go ahead.
On a modern art painting, there are 11 green dots in the first row, 13 green dots in the second row, 15 green dots in the third row, and 17 green dots in the third row, and 17 green dots in the fourth row. If this pattern continues, how many green dots will there be in the fifth row?
Hannah's group?
19.
Okay. And why?
Because it's going up like 2 each time.
Yeah. Again, real simple there, okay. Alright, next question.
Danny got a new video game. He scored 1 point on the first level, 2 points on the second level, 4 on the third, and 8 on the fourth. If this pattern continues, how many points will Danny score on the fifth level?
Matt Wick,
Say your answer.
the math major.
Andrew has our answer for our group.
Okay.
I got 16
And why?
because it's doubling again.
Okay.
Nice.
Yeah, like they said right there. It's doubling every time.
Good wild guess. Gosh, I didn't think of that.
Alright.
Anna bagged plastic bottles after recycling drive. She placed 3 bottles in the first bag, 5 in the second bag, 9 in the third bag, and 15 in the fourth bag. If this pattern continues, how many plastic bottles will Hannah put in the fifth bag? C, do you have an answer for us?
Does anybody have an answer for us? Yeah.
23.
Okay. And why?
Because you add 2 to adding the pattern each time. So it goes up 2, 4, 6, 8.
So you
Got
add
it.
2 each time to what you're adding.
Okay. Good job.
Thank you.
Couple more.
At a birthday party, the first child receives 6 smiley stickers, the second child receives 9, the third receives 12, and the fourth receives 15. The fifth child receives 18. If this pattern continues, how many smiley stickers will the sixth child receive?
Matt, I'm going to give you another chance.
Alright.
What do you got for me?
I know it's a tough question, but I'll go with 21.
21. Why did you go with 21?
Because it's adding 3 every time.
Okay. One more and then we'll go back to the PowerPoint.
Thank you, Professor Mattheis.
Tim's Pizzeria made 5 pizzas on Wednesday, 6 on Thursday, 9 on Friday, and 14 on Saturday. If this pattern continues, how many pizzas will the pizzeria make on Sunday? So do you have an answer this time?
No.
Anybody got one?
Colton?
21
21. Why?
just keeps adding 2 to the number that's adding, so 5 plus 1, then plus 3, then plus 5, and plus 7.
Okay. All right. Good job. All right. We're going to go back to the PowerPoint here now. Okay, so After our activity, we're just going to come to close here and how to end a class for a logical mathematical learner. We're just going to give you some examples on how a good way to be what a lesson would be. You made the student think all day, so don't stop now. Lead the student thinking in multiple ways. Give the student a sneak peek or preview of the next section in small doses. So you're not really teaching them what the next lesson would be, but you give them an idea in their mind so they can think about it and be ready for next class. End with another possible paradox like we did to begin the class. Yeah, go ahead.
You can also then give a handout with questions and explain to the students how you may not know how to do this, but at least give your best shot so that when they come to class next time, they'll know at least what the lesson will be about. Finish by reading a chapter of a class book, and then end off by saying, "Have a great day."
Okay. That's it.
Thank you.